Hi, in this lesson I will talk about time-location diagrams and I will also introduce you Tilos. For this matter, I will take support from a presentation I did some time ago for an AACE International Symposium. This is the short version of that presentation. If you have no idea what AAC is about, please just visit its website. Okay. Time-location diagrams are the core business of what we are about to learn in this course. They are known under several different names all over the world. For instance, we have time-location diagrams, of course, linear scheduling method or LSM, time chainage, line balance, term that comes from manufacturing in factories, Mars chart, French diagram. I cannot assure you that French people invented this. All these names mean the same. In our course, we will always use the terms time-location or time-distance diagrams, because they are the most popular, the most used, and because that is how the provider of Tilos named it. First of all, let's make a quick review of the techniques planners are using these days to plan projects. Let's start with the network diagram. The tasks are shown in information boxes. There is a good visibility of dependencies between activities and a good visibility of the critical path too. The problem is that it doesn't show any relation with a time scale. It's pure logic. That's why today it is barely used. The most popular planning technique, without any doubt, is the Gantt chart. This one adds a time scale. There is a good visibility of task dependencies and the critical path. Most planning softwares are based on Gantt charts. However, there is no location referral. By the other hand, big project plans could be confusing because good visibility gets lost. If you ever seen a Gantt chart printed in many sheets of paper, you probably know what I mean when I say that good visibility gets lost. For many infrastructure linear projects like piping, railways, highways, tunnels, bridges, and transmission lines, Gantt charts are not enough. For this kind of projects, time-distance diagrams suits better. In these projects, repetitive tasks coexist, or different tasks are executed simultaneously in different places. Besides, the work could be done in different directions, from right to left or from left to right. These diagrams deal very well with all those situations. These types of diagrams, likewise in Gantt charts, show the activity in a time scale. Besides, they show start and end task location coordinates as well. Combined with a site plan and important locations, it yields a straight position of the task to the site map. Additionally, it shows the direction in the working activity. Moreover, it can show you the speed of the task. A little slope means that the speed is faster. The more bigger the slope, the more time the activity takes to finish the task. In time-location diagrams, we can see crossings and clashes. We can reprogram, giving a simple graphical solution. This is the representation of a Gantt chart versus a time-distance diagram. You can have many interpretations for the Gantt chart. Instead, the time-location diagram has many representations, each one with its own interpretation. We can represent restrictions on these diagrams and achieve a solution. We can point out warehouses and stationary task locations. This means tasks performed in just one point of the distance scale. We can also see the different speeds that activities adopt according to the terrain. This one is a good view. We see the meteorological report overlay on the diagram. Nobody would choose to work in certain places during the worst climate, right? Now, let's talk about the tool you are about to learn, Tilos. In fact, all the examples I've been showing you were made with Tilos. Tilos means time location system. It is developed by the German company Linear Project, now belonging to American Trimble. Tilos is a project management system, and it is based on best planning and scheduling practices, but it is improved because of the use of the distance scale. Tilos is a graphical tool, very intuitive to schedule tasks. And the best is the use of what you see is what you get technology. It means that you will always see the final result of your plan. Draft printings are not necessary. I will show you some examples of plans made with Tilos. In this highway, some pictures were added to show the different locations. There are 2 lanes. Each one is treated as a different sub-project, but presented as one. This plan consists in many stationary tasks. The execution flow is clear. Here, we can see the erection of transmission line towers represented. During winter time, execution is avoided. In this view, we watch 2 tunnels interconnected by 3 points. Moreover, there is a specific coordinate that needs dewatering. This is a very extensive project and supported on a satellite map. Finally, I would like to conclude this lesson by mentioning that Tilos also manages Gantt charts. As a matter of fact, once you schedule your plan on a time-distance diagram, you will have as a result its Gantt chart too. We can include them for a better understanding of your plan. It is you who decide the best way of presenting your plan. In the next lesson, we will begin using the software.